Hi everyone, welcome back. Today I'm going to talk about classification of adhesive materials. In the last class I was focusing about adhesive and mechanism of adhesives, theories of mechanism and factors which affect the adhesive strengthening process. So the today's class is all about classification of adhesives. So based on the occurrence of the adhesives or based on the place where we are getting the adhesive material, we can classify the adhesives in the following two categories. One is going to be a natural adhesive material, nature based materials, so which are exist in the nature itself. The second one is going to be a synthetic adhesive. So here we are going to synthesize the adhesive material either in the laboratory or using the natural synthetic monomers. And first I am going to talk about natural materials or natural adhesives. Basically, there are three type of material. We keep on using this material as traditional adhesives, and the first one is going to be a cellulose based adhesive material. Cellulose. We all know that cellulose is the class of adhesive which is being used in right from the beginning of 20th century, and cellulose is the material which can be extracted from the natural materials. And the following is the structure of following is the structure of cellulose material. Oxygen will be available over here, then there will be a linkage will be over here, available over it. Here one CH2OH, then OH moiety, then one more OH moiety. So this is the structure of cellulose in fact. Okay, so the cellulose will be dissolved in the water, and that solution will be heated, and temperature will be raised to maximum of to the maximum of 150 degrees centigrade, and we are going to convert that into highly viscous form of suspension. So that will be used as a natural adhesives, and it can be used for various purposes like for making storms and binding notebooks, and for other domestic and industrial applications. But when you look at the merits and demerits of this kind of cellulose based adhesives, it will have when you look at the merits of the cellulose adhesives, it is cheap and can be easily available. But when you look at the demerits, here it is not highly resistant towards water, as well it is not it don't have the resistant behavior against acids and base. It is easily affected by the acid and base and all, and also it will be easily degraded by the kind of microorganisms also. So therefore we cannot use this for cellulose based adhesives over a period of long time, because it can be easily degradable one by either microorganisms or some chemicals and even water molecules, because whenever water molecules made the cellulose based adhesives, it will try to form a kind of hydrogen bond. Hydrogen bond is nothing but a kind of attractive force, or we can call it as secondary force or van der Waals bond, and it's an attractive force between hydrogen and other electronegative atom is called as hydrogen bonding. And due to the formation of this hydrogen bonding, it will try to weaken the bond between the adhesive and the adherent surfaces. So these all are the demerits of cellulose material, cellulose based adhesives. And the second one is going to be a shellac. So basically this is a kind of nature based material. It is extracted from the kind of microorganisms segregated from the female bugs. So this can be dissolved in the water. Shellac will be dissolved in the alcohol, not water, this is alcohol, and it will be used as adhesives. When you apply these adhesives, it should be applied in the hot conditions, because when you allow this mixture alcohol and shellac material at room temperature, will try to harden. So we have to melt the material, and it has to be applied under molten conditions. And the molten conditions, this is allowed to room temperature. It will attain the kind of strong. It will attain the room. Once it attains the room temperature, it will try to form a kind of strong bond between the adherent and adhesive materials. So such class of adhesives is called as shellac materials, and it can be used for making coating on the conveyor belts. And the third one is going to be asphalt. So asphalt is nothing but it's a kind of nature-based adhesive material. It is extracted from the crude oil. In fact, it is the last or the final product of crude oil. When the crude oil is subjected to the refinery process, at a different temperature, we used to get different solvents and hydrocarbons and fuels. For an example, like petrol, diesel, kerosene, naphtha. Depending upon the boiling point of the liquid, we will get such projects in the different temperature level, and the final we are going to get the kind of waste material that's called asphalt, and this is used for making roads as well, waterproofing roof and all. So these three are the kind of old and traditional nature based adhesive material. Even still now it is used in practice. It is this application of this materials still in practice. Alright, and the second one is going to be a synthetic adhesive material. So depending upon the type of mechanism is being followed, or depending upon the chemical reactions is being operated, we can classify the synthetic adhesives into the following category. One is called thermoplastic based cellulose material, and another one is going to be a thermosetting plastic based synthetic resins. And what are the material comes under this thermoplastics? There are two adhesive materials being used as a thermoplastic based adhesive material. One is called cellulose nitrate, and the second one is going to be PVC, polyvinyl chloride. So these two are the kind of materials is being used as a thermoplastic based synthetic adhesives. But when you look at the origin of cellulose acetate, basically it is derived from the cellulose, some modified natural adhesives. We all know that the cellulose will have some limitations, so such kind of limitation can be eliminated by synthesizing cellulose nitrate, and cellulose nitrate can be easily synthesized from cellulose. So when the cellulose is nitrated with the help of nitrating mixture, for this we need to use HNO3 and considerable amount of sulfuric acid. This is called the nitrating mixture. When nitrating mixture is treated with cellulose, all the three OH groups which is available on the cellulose gets nitrated. So as a result, we are going to get the compound like this. So CH2OH. So this hydrogen will be replaced. In place of that, NO2 will come and attach over here. Here also one NO2 will comes, and here also one nitro group will come and attach over here. And this is called cellulose nitrate. So this compound found to have very good resistance towards chemicals, even water molecules, and it is not easily affected by the microorganisms also. And because of this nitrate group, it is not easily affected by the microorganisms, and it will show excellent water repellent behavior also. So therefore, such class of adhesives can be utilized for various purposes, like in industrial sector, even in the domestic sector. It used to bind the kind of wooden material, plastic material, even glass materials can be easily binded with the help of the cellulose nitrate based adhesive materials. So this comes under the category of thermoplastics. But when you raise the temperature of operating temperature or the temperature of the surroundings, when it reaches the optimum level, it will become soft and flexible. So therefore, we can able to break the bond, and the adherent surface can be separated easily. So therefore, such class of adhesives comes under thermoplastics. And the second one is going to be polyvinyl chloride, PVC. Basically, PVC is synthesized from the vinyl monomer. It's called vinyl chloride. CH2 double bond CHCl is called as vinyl chloride. When the vinyl chloride is subjected to the polymerization solution polymerization process. Now, what do you mean by solution polymerization? Solution polymerization is nothing but vinyl chloride has to be dissolved in the solvent in the presence of initiator. So once the initiator is introduced in the system polymerization process, it will go and initiate the first monomer, and the first monomer will initiate the second monomer. So when the first monomer is initiated by the initiator is called as initiation. Once the initiation process started, then the first monomer will go and initiate the next monomers, and this will be keep on happening inside of the polymers in the solution compartment, and that process is called as propagation process. Once the propagation gets completed, then now we need to terminate the reaction, and the termination can be done with two processes. One is called coupling type of termination, and the second one will be disproportionation. During the coupling process, there are two radicals will be attached together to give one long polymer chain, and in the case of disproportionation process, one hydrogen atom will be replaced from one moiety and it will be attached to this next one. As a result of this, we used to get one saturated and one unsaturated polymer. So we will be getting the polymer like this. So therefore CH2 CHCl. So the double bond will be replaced and n number of monomers will be available over here. That's called repeating unit, and this is called as degree of polymerization. DP stands for degree of polymerization. If you get more DP, that means molecule will be more. As a result, it used to form a kind of strong bond on the surface of the materials. Okay, this comes under thermoplastic based PVC, and this one also has to be applied in the hot conditions. When you allow this molten form of thermoplastics, it will try to form a kind of strong bond between the adherent and adherent surfaces. And when you look at the property of this thermoplastic based PVC adhesive, it is highly resistant towards corrosion, and it is not easily affected by the kind of even strong bases and all, and also it is not affected by the microorganisms, so it is not biodegradable as well. So therefore it can be highly preferable low cost thermoplastic materials. It is highly found useful in the industrial sectors. Now I am going to talk about thermosetting based plastics resin. So under this category, we are going to focus about four classes of synthetic resins. The first one is going to be epoxy resin. Epoxy resin, it is a kind of synthetic resin. Under the trade name of, it is sold in the market under the trade name of Formaldehyde. The second one will be Backlight, and the third one is going to be urea formaldehyde resin. Urea formaldehyde resin. Urea formaldehyde resin. And the fourth one is going to be cyanoacrylates. This is used to form a quick bond, like quick fix. It is sold in the market under the trade name of quick fix. Cyanoacrylates. And when you look at the advantage and application of these kind of thermosetting based adhesive material, they all comes under condensation polymerization process. As a result, it used to form a kind of 3D cross-linking network once it is applied on the surface of the material, either in the room temperature or molten state, and it is not easily affected by kind of microorganisms, strong acid and base, and it is highly thermal and electrical insulators. Such class of adhesives can be used as a electrical insulator also. And now we are going to focus about synthesis of epoxy resin. So basically, the epoxy resins can be synthesized from the corresponding monomer called epichlorohydrin and bisphenol A. So these two are the kind of monomers can be utilized for the preparation of epoxy resin. Synthesis. CS3. This is called bisphenol A. Bisphenol A, and it can be easily synthesized from the two materials. One is phenol. So there are two phenol moieties that are involved, and 1 mole of acetone. This is acetone moiety, and these two are phenol moiety. When these two are subject to the condensation process, it used to produce bisphenol A. This bisphenol A is allowed to react with epichlorohydrin, CH2. This is a three-membered ring chlorinated hydrocarbon. When this chlorinated hydrocarbon, 3-member chlorinated hydrocarbon is allowed to react with bisphenol A, epichlorohydrin. Hydrogen is allowed to react with this compound in the presence of acid catalyst H plus. It's a condensation reaction, so it involves the replacement of 1 mole of hydrochloric acid, and also it also involves this simple molecular rearrangement. So this hydrogen will come and attach with this oxygen, and there will be a ring opening will takes place. Here the C and oxygen bond will be gets broken. Now it forms, so n number of monomers we supposed to take oxygen, CH2, CHOH. In fact, this bond will get broken and this will form a kind of molecular arrangement. It forms hydrogen, CH2, CHOH, then CH2. And n number of monomers are getting involved in it. The number of n is nothing but degree of polymerization. The degree of polymerization may be varied from 10 to 20, and to the maximum extent of it goes to 20. So depending upon the n value, it will try to form a kind of strong adhesive materials. Due to the presence of this ether linkage, RO moiety is available over here. So due to the presence of this ether linkage, this is highly resistant towards water molecule. So water, it do not form any kind of hydrogen bond with the water molecule. As a result, it is not easily affected by the water molecule, and also do not involve any kind of secondary van der Waals formation, and it is not easily affected by acid and base, because it's a kind of condensation reactions getting involved in it. As a result, it used to form a kind of 3D cross-linking. Due to the presence of this OH group, it involved a 3D cross-linking network. So once the adhesive material is applied on the surface, it will try to react with the atmosphere oxygen, and it forms a cross-links on the surface. So during the cross-link formation, it will tightly bond at the adherent surfaces. So that's all about the preparation uses of adhesive material. It's excellent adhesives in the industrial sectors. It's highly found useful to stick, glass plates and metal plates. Even it is highly found useful to stick the stone materials also. And next one is going to be synthesis of backlight. Synthesis of backlight, or this is otherwise called as phenol formaldehyde resin. Phenol formaldehyde resin. The phenol formaldehyde resin or backlight can be synthesized from the following material. This is phenol moiety. Search for OH. For this, we can take 1 to 3 moles of formaldehyde. So HCHO is the formaldehyde chemical structure, and it can be written as CH2O. 1 mole, this is 2 moles of formaldehyde, and this is going to be 3 moles of formaldehyde. When 1 mole of formaldehyde is allowed to react with 1 mole of phenol, it will give mono substituted phenol, OH. That is, there will be a chemical rearrangement. This hydrogen will go and attach with this oxygen, so therefore it forms CH2OH. And if 2 moles of formaldehyde is allowed to react with 1 mole of phenol, now it will form disubstituted phenol. So CH2OH and CH2OH. In fact, it will try to go to the ortho dash and meta position, because the OH group is the kind of ortho and meta directing group. Once the ortho position is filled, it will go to the ortho dash position. This is ortho, this is ortho dash position, this is ortho position. If both the positions are occupied, then it will direct this OH group direct the incoming group to the meta position. So if 3 moles of formaldehyde is allowed to react with 1 mole of phenol, it will give 3 tri-substituted phenol. So OH, CH2OH, then it becomes CH2OH. Now these mono, di and trisubstrate phenols are mixed together, or it will try to react with each other in the presence of acid catalyst. So once it react with each other in the presence of acid catalyst, it will try to give the three-dimensional network resin. That's called the backlight. So again the condensation reaction will take place, becomes OH, becomes CH2. There will be a condensation reaction will be taking place. As a result, 3D structure cross-linked, this chain will keep on go. So this carbon will attach to this carbon atom, it will go like this and becomes OH. And this is called 3D structure cross-linked backlight, or we can call it as phenol formaldehyde resin. So this is a kind of condensation polymer, and it will have excellent insulation behavior. So it can be used as a very good thermal and electric insulator, and it is highly found useful for manufacturing switches and other boxes and all. And also, in addition to this, such class of resins is also found useful as adhesive material. And when you apply this polymer on the surface of adherent, it will try to undergo kind of 3D cross linking. So during the 3D cross linking formation, it will try to form a kind of chemical structure like this, and once it attains this chemical structure, it will form a strong bond between the adherent surfaces. And when you look at the physico-chemical property of this adhesive material, it is not affected, it is not easily affected by any type of chemicals. Even maybe a strong acid or strong base cannot affect this material, and it is highly inert in nature, and it can be used as an excellent thermal and electrical insulators. And also it is not affected by the water molecules, very high resistant towards water molecule, also water repellent. So therefore this class of adhesives is highly found useful in the industrial sectors. Next I am going to talk about the third class of synthetic resin, that is called urea formaldehyde resin. The previous one was phenol formaldehyde resin, the second one will be urea formaldehyde resin. So this one can also be used as a synthetic adhesive. So now we all know that urea is nothing but it's kind of diamide, CONH2, CONH2. So when the diamide or urea is reacted with either 1 or 2 moles of formaldehyde. For an example, if 1 mole of formaldehyde is allowed to react with CH2O and 2 CH2O, 1 mole of formaldehyde is allowed to react with 1 mole of urea, then there will be a simple molecular rearrangement will take place. This hydrogen will come and attach with this oxygen. As a result, it will form CONH, then CH2OH. If 2 moles of formaldehyde is allowed to react with this 1 mole of phenol, now what happens? It will produce C double bond O, NH, CH2OH, then NH, CH2OH. So di substitution will take place. So therefore it will increase the functionality of the monomer. This will now this act as a monomer. So now monomer is nothing, functionality is nothing but number of reactive sites which is involved in the which is available on the monomeric unit. Here it will have only one functional, it has two functionality over here. Now this molecule will try to undergo polymerization process, and it forms a kind of resin. So the resin is called as urea formaldehyde resin. So NH, CH2O, it goes like this. NH, CH2 will go like this. So this is going to be a urea formaldehyde resin. And when you look at the various physico-chemical property of this resin, this is highly found useful in the industrial sectors, and this is highly water resistant, and it's not easily affected by the kind of strong acid and base, and it can be used for a variety of applications. It can be used in the even room temperature itself. So once it applied on the surface of the adherent, it used to form a kind of cross links due to the formation of chemical reactions, due to the involvement of chemical reaction, it used to form a kind of cross links. So that cross links lead to the formation of strong bond between the adherent surfaces. Well, now I am going to talk about another class of polymer. In fact, it belongs to the category of when you look at the structure of this material, it seems like a adhesive polymer, but it will behave like thermosetting resins. That's called cyanoacrylates. Cyanoacrylates is the another class of adhesives highly found useful in the variety of sectors. Now, this is the structure of cyanoacrylate. CH2 double bond CH, that is COO CH3 is acrylate. In place of one hydrogen, now we are going to substitute one cyano group. This is cyanometacrylate, and when this monomer is allowed to undergo polymerization, solution polymerization process in the presence of initiator, and we need to carry out this polymerization at 70 degrees centigrade, and it forms kind of polycyanoacrylates. CH2 CN. So this is what chemical structure will be modified when the adhesive is applied on the surface of the adherent. So the reactant, this is the monomer, and the monomer will be available in the solution compartment itself, and initiator will also available. When the cyanoacrylate is applied on the surface of the adherent surfaces, it will try to interact with the oxygen molecule, and it forms kind of polymerization reaction. So during the polymerization reaction, the polymer's molecular weight gets built up. So during this molecular weight build up process, so it used to form a kind of strong chemical bond on between the surface of the adherent, and this is cyanoacrylates, polycyanoacrylate. So this is a kind of very good adhesive, excellent adhesive used in the variety of sectors. For example, this is sold in the market under the trade name of Quick Fix. Even for 5 rupees we used to get this material, and this is the kind of raw material which is available in the Quick Fix. When the Quick Fix is applied on the surface, within 30 seconds we used to get a very strong bond between the surfaces. And when you look at the various physico-chemical property of this cyanoacrylates, it is highly stable enough even at any circumstances. It can almost all the kind of thermosetting resins can be used as a insulators, because it's can able to withstand more than 300 degrees centigrade, and it is not easily affected by the kind of strong acid and strong bases, and it is not also not easily affected, in fact is highly resistant towards water molecule, because such class of material do not form a kind of hydrogen bond with water molecule. As a result, is highly water resistant. And also such class of materials can be used as a insulating material, because there is no free electrons available on it, because all electrons and the functional groups are get involved in the polymerization or the 3D cross linking. As a result, it is highly tightly packed enough. So therefore, it do not conduct electricity as well as temperature. So such class of polymers are highly found useful in the variety of industrial and automobile, even aircraft and industry sectors. All these kind of thermosetting based polymers used as adhesive resins in the aircraft used by the aeronautical engineers. So that's all about the synthesis and applications properties of various classes of thermo and thermosetting resins. So I just want to summarize the class of synthetic and thermosetting, or we can call it as natural and synthetic adhesives. Depending upon the origin or based on the occurrence of the adhesives, it could be classified like natural and synthetic. Natural materials are existing in the nature itself, and that can be modified or that can be used as such as adhesive material, but it will have a low chemical resistance and water resistance. So therefore, we are in a position to either modify the structure, or we need to find the suitable adhesive material for the application of to apply the kind of adhesives in the industrial sectors. So therefore, very synthetic thermo and thermosetting based adhesives came into act, and based on the chemical reactions getting involved in it, we can classify the synthetic adhesive into the following two categories: thermo and thermosetting.
There are two polymers two material comes under thermo. One is cellulose nitrate, and when the cellulose nitrate is allowed to react with alcohol, and we can produce collidine. It's a kind of another adhesive. And the second one will be PVC, polyvinyl chloride. So that can also be used as a adhesive, but it has to be applied in the hot condition. And the second one, thermosetting based resins, where we are going to use four types of polymers as thermosetting resins. The first one is going to be epoxy resin, and the second one will be backlight. Third one will be urea formaldehyde resin, and fourth one will be acrylate resin, cyanoacrylates. Now when you look at the property and application of this kind of thermosetting resins, this is highly resistant towards water and chemicals, and there are like backlight, urea formaldehyde resins, and araldite, that is epoxy resins. They are highly resistant towards electricity as well temperature, so it can be used as a thermal and electric insulator. And when you look at cyanoacrylates, this is highly found useful to produce quick bond between the adherent surfaces, because within 20 or 30 seconds itself it used to form a very strong bond between the adherent surfaces due to the formation of kind of polymer cross links, and also due to the presence of CN group in the polymer. It is highly resistant as well. It used to form a kind of strong bond between the adherent surfaces. So that's all about the classification, application, and uses of synthetic and natural adhesives. Thank you very much for your patient listening. Thank you all.